Now we simplified out the 3's and the 5's here. And now, so we will have 2 times 2 times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64, times 2 is 128, times 5. So we have 128 times 5 all over 1. So 128 times 5 will give us, it looks as though 0 carry a 4. Let me see, that's 14 carry a 1. That's 640 over 1. So our final answer is $640. That's how much his commission would be. Okay, problem number 3. Sam bought 6 packages of hamburger at the supermarket. If each package contained 3/4 pounds of meat, how much hamburger did Sam buy in all? So it's 3/4 times 6, because it's 3/4 pound in each package. So we do the prime factorization. We have 3 times 2 times 3 all over 2 times 2. We have one set of 2's that we could simplify out, and we will have 9/2 pound. Okay, now we go down here to number 4. It says find the area of a sheet of wood that is 7/6 yards wide and 4/3 yards long. So first of all, a sheet of wood is in the shape of a rectangle. So we have area is equal to length times width. So we have area is equal to the length is 4/3 and the width is 7/6. Now the prime factorization of 4 is 2 and 2. Prime factorization of 7 is 7. We add 3, which is already prime, and the prime factorization of 6 is 2 times 3. These 2's will simplify out, and we will be left with 14 over 9. But since we have yards times yards, it will be square yards. And that is our final answer. Okay, our next problem, number 5. In the primary election, 5 candidates competed for their party's nomination. The circle graph pie chart shows the fraction of the votes each candidate is expected to receive based on telephone surveys. If 200,000 people vote, we have this broken down here. You have, these are the candidates, and these are the fractional amounts of the votes that they will get. Now remember, these fractions are out of the 200,000 people. So now, get down here to the question. It says, how many votes would Mr. Williams expect? So we have Mr. Williams, which is 1/4, times, and that's out of 200,000. Now, we'll make that 200,000 over 1, and that's equal to, now we can do the prime factorization. So, okay, what I did here, I took the liberty of finding the prime factorization of 200,000. And I broke this down to be 200 times 1,000. 200 breaks down to 2 times 100. And we already know 100 breaks down to 2 2's and 2 5's. Now with 1,000, we have 10 times 100. We know 10 breaks down to 2 times 5. And 100 again breaks down to 2 times 2 times 5 times 5. Okay, so now what I did was I wrote all of these together. So we had 1, 2, 3, 4, 5, 6 2's, which we have here. And then we have 1, 2, 3, 4, 5 5's. So now, we write that out. We have that 6 2's and 5 5's. And then in our denominator, we know 4 breaks down to 2 times 2. So we had 2 sets of 2's that we lose here. And our denominator is 1. And we know this would end up giving us, what's that, 50,000. So our final answer would be 50,000 votes. Now, it says how many votes would Miss James expect? So the first thing we need to do is see the fraction that Miss James have. Let's see, Miss James. Now you could easily look at it in your course pack, but I have to scroll back up here. So she has 3/20ths. So we would take 3/20ths times 200,000. We'll put that over 1. And we already know the prime factorization of 200,000. We know it's 6 2's. And we know it's 5 5's. And our denominator 20 breaks down to 2 2's and a 5. So we had 2 sets of 2's and also 1 set of 5's here. So we know our denominator is 1. And now our numerator. We have, let me see, that's 10, that's 100, that's 1,000, that's 10,000. We have 30,000 divided by 1. So she would expect 30,000 votes. And that is it. Now we have section 4.4 through 4.5, adding and subtracting fractions, least common denominator, and equivalent fractions. Let's consider this visually first. We look here at this first shape here, and we have 1, 2, 3, 4, 5, 6. So our denominator will be 6, and our numerator will be the shaded area, so it'll be 2, 6. Here, we still have 6 for our denominator, and the shaded value is 1. So now we add 2 6 plus 1 6, which we know would be 3 over 6. Will give us 3 6. Now, we can also simplify this because we know the prime factorization of 3 is 3, and the prime factorization of 6 is 2 times 3, and these 3 simplify out, and that leaves you 1/2. So now we come down here. To do this numerically, we can think of it in much the same way. We have 5 12ths minus 3 12ths. We keep the denominators the same, and 5 minus 3 is 2. So we add 2 over 12. Now, what we would need to do next here is simplify. So we would take 2, and then the prime factorization of 12 is 2 times 2 times 3. These 2's will simplify out, and that will leave you 1 over 6. And that will be your final answer. Now in a nutshell, to add or subtract fractions with like denominators, just add or subtract the numerators. Keep the denominators the same. Remember to check that your final answer is in lowest terms, and change any improper fractions to mixed numbers. So this is what we need to do here. We have 5/8 plus 1/8. So we would say 5 plus 1 is 5 plus 1, and we would keep our denominator as 8. So 5 plus 1 is 6, and our denominator is 8. Well, we could simplify this. We take the prime factorization of 6, which is 2 times 3, and the prime factorization of 8, which is 2 times 2 times 2. These two simplify, and you're left with 3/4. Now we go here to subtraction. Now we have -4/9 minus 2/9. Now we know they have the same sign, so that means we add them together and carry the sign. So 4 and 2 we know will give us 6, and we'll carry over our 9. Now we could simplify, or we could take out the prime factorization of 6, which is 2 times 3, and the prime factorization of 9 is 3 times 3. These 3's will simplify, and you will have a -2/3. Now we go here to number 3. We add our fractions here. Our denominator stays 7. 6 plus 3 is 9. Now, we know 9 and 7 has nothing in common because 9 will become 3 times 3, and 3 and 7 has nothing in common. But we're also asked to change this to a mixed number. Now 7 goes into 9 once. Our denominator stays 7, and we have a remainder of 2. So it's 1 and 2 7's. Now if you didn't know that offhand, you could do this. You could go to the side, and say 7 goes into 9 once. You have a remainder of 2. So what you would do here is the number in front of your remainder, that would be your whole number. Your denominator would stay the same, and your numerator would be your remainder, which we have here. Now we go here to number 4. And we have the same denominator, carry the denominator over. Negative 2 plus 8, we know gives us 6. Now we take the prime factorization of 6, which is 2 and 3, and the prime factorization of 15, which is 3 and 5. These 3 simplify out, and you're left with 2/5. Now we would do equivalent fractions. It says adding and subtraction fractions with unlike denominators takes a little more work. So first we will have to build a little background knowledge. Equivalent fractions are fractions that look different but have the same value. For example, 1/2, 2/4, 3/6, 4/8, and 5/10. All are equivalent fractions because all of these equal 1/2. To form a fraction equivalent to a given fraction, remember that we cannot change the value of the original fraction. Therefore, we must be careful always to multiply the fraction by a form of 1. We know multiplying by 1 does not change anything. So we look here at these examples. Now, looking at these examples, we look at our denominator. We have 5 here. Now, if you look over here, they want us to give from 5 to 20. So we ask ourselves, 5 times what gives us 20? So now that we know that 5 times 4 is 20, we will multiply the numerator and denominator of this fraction by 4. So 5 times 4 is 20, and 3 times 4 is 12. So 12 over 20 is the equivalent fraction. Now we do the same thing here. 7 times what is 21? We know 7 times 3 is 21. So we will multiply the numerator and denominator by 3. 7 times 3 is 21, and 9 times 3 is 27. Now, it says adding and subtracting unlike fractions. You must change to equivalent like fractions before you can add or subtract. It is best to change both denominators to the lowest common denominator, the smallest number divisible by both denominators. Once you identify the LCD, change both fractions to equivalent fractions with the LCD by multiplying each by a form of 1. So now we have 3/10 and 1/4. Now what we have to do is find the common denominator of 10 and 4. Now 10 and 4, one common denominator is this here. Since you all know how to simplify already, we could do this. We could just say 10 and 4. We could say the common denominator is 20. So we know 10 times 2 is 20. And so we will multiply these both, the numerator and denominator, by 2. And then here 4 times 5 is 20. We'll multiply the numerator and denominator by 5. So 10 times 2 is 20. 3 times 2 is 6. 4 times 5 is 20. 1 times 5 is 5. Now they have the same denominator. We can add the fractions. That will give us 11 over 20. Okay, now we do the same thing here. Common denominator or least common denominator of 2 and 9 is 18. So we ask ourselves, 2 times what is 18? 2 times 9 is 18. So we multiply the top and bottom by 9. And then we say 9 times what is 18? Is 2. So we multiply the numerator and denominator by 2. 1 times 9 is 9. 2 times 9 is 18. 9 times 2 is 18. And 7 times 2 is 14. So we add them together. 9 18s plus 14 18s is 23 over 18. And they have nothing else in common, so we could leave that as it is. Now, we scroll here to the next page. Now we have negative 3/8 plus 9/16. The common denominator of 8 and 16 we know is 16. So we'll multiply this numerator and denominator by 2. And we will multiply this numerator and denominator by 1 because we already had the 16. Negative 3 times 2 is a negative 6. And 8 times 2 is 16. 9 times 1 is 9. And 16 times 1 is 16. Now we know negative 6 plus 9 is 3, and it's all over 16. And that is your final answer.